Um, Imagine standing next to an animal whose shoulder is, well, taller than a single-story house.
Which is already pretty hard to picture.
Right. Now picture that same creature carrying highly modified teeth tusks. Really that way as much as the grand piano.
It sounds completely made up.
It sounds exactly like something out of a science fiction movie. Or, maybe a fantasy novel. But it was very, very real.
Welcome to today's deep dive into the source material.
Yes, welcome.
Today we are putting a magnifying glass on one of the most astonishing creatures to ever walk the earth. And we have a fascinating single source for you today.
A really comprehensive Wikipedia article.
Exactly. On a behemoth known as Mammut borsoni, or Borson's Mastodon.
And our mission for you today is threefold.
Yep. First, we're going to explore the sheer unbelievable scale of this animal.
Then we're going to figure out why scientists insist on putting its name in quotation marks.
And finally, we'll reconstruct exactly what the world looked like when it was alive. Because it is completely understandable if your mind immediately went to woolly mammoths or modern African elephants when you heard those dimensions.
We all have that baseline.
We do. But what we're looking at today is an incredible, often entirely overlooked chapter in Earth's history. Borson's mastodon isn't just another extinct elephant relative.
Far from it.
It's a creature that fundamentally challenges our understanding of mammalian evolution, physical scale, and how entirely different species can end up looking remarkably similar.
It really rewards the curiosity of anyone willing to look past the famous Ice Age megafauna we all know so well.
Absolutely.
Okay, so let's unpack this sheer scale, because the numbers here are genuinely hard to wrap your head around.
They really are.
When we talk about Mammut borsoni, we are talking about a true titan. I know our source highlights some specific fossil sites, particularly in northern Greece, that give us a clear picture of just how big these animals got. Give us the raw measurements. What are we actually dealing with here?
Right, so based on partial skeletons found in a Greek village called Melia, scientists estimate that fully grown males of this species reach shoulder heights of up to 4.1 meters.
Wow.
That is about 13.5 feet straight up in the air.
That is staggering.
And as for the weight, conservative estimates put them around 16 tons, or roughly 35,000 pounds.
To put that into perspective for everyone listening, you would need to stack roughly 8 average-size passenger cars on a giant scale to match the weight of just one of these males.
Just one.
How does that compare to the giants we are more familiar with?
At 16 tons, it is significantly heavier and taller than any modern elephant species.
Right.
It also completely dwarfs the famous American mastodon, which is what most people picture when they hear the word mastodon.
Sure.
These estimates actually put Borson's mastodon in the running for the title of the largest land mammal to have ever lived anywhere on Earth.
The largest ever.
Yeah, for a very long time, that undisputed heavyweight title belonged to Paraceratherium.
The giant rhino.
Exactly, the towering, hornless rhinoceros from ancient Asia. But the discoveries in Greece suggest Borson's mastodon was right there in the exact same weight class, battling for the top spot.
And we haven't even talked about the most shocking detail yet. I'm looking at the notes on its tusks, and frankly, the physics of this don't even seem possible. Just how extreme were these modifications?
We are talking about the longest known tusks of any animal ever discovered.
The longest ever.
Ever. One preserved tusk from a probable male specimen found at that same site in Greece measured 5.02 meters in length.
5.02 meters.
That is 16.5 feet of solid ivory.
That's insane.
A single tusk of that size would have an estimated life mass of around 137 kilograms or 302 pounds.
Wait, go.
That means you have over 600 pounds of dead weight hanging off the front of this animal's skull, just in tusks alone.
Just imagine trying to navigate a dense European forest with 2 16-foot surfboards strapped to your face.
It wouldn't be easy.
The turning radius must have been absolutely terrible. If you get spooked by something, you can't exactly just whip your head around without taking out 3 trees.
The mechanics of simply moving through a landscape would have dictated its entire lifestyle. Think about the immense, hyper-developed neck and shoulder strength required just to lift its head off the ground to walk.
Just to take a step.
Exactly, let alone to use those tusks to interact with its environment or fight rivals. The muscular architecture of its front half must have been incredibly bulky.
Like a massive biological counterweight to keep the animal from just tipping forward.
Precisely.
So with tusks that massive, I have to wonder, Was every single one of these animals walking around carrying 600 pounds of ivory on his face, or did that vary?
Oh, it definitely varied. We see a drastic level of sexual dimorphism here.
Meaning the males and females looked incredibly different.
Right. In 1958, a fully grown skeleton was excavated from a sinkhole near Kaltensenheim in central Germany. Because of its proportions, scientists determined it was a female. She had a shoulder height of about 3.2 meters, so roughly 10.5 feet, and weighed an estimated 7.8 tons.
Wow. So a fully grown female was literally half the size of the males.
Basically half, yes.
That is an extreme difference. I mean, a nearly 8-ton female is still a massive animal by any modern standard.
Definitely.
That's roughly the size of a very large modern African bull elephant. But next to a 16-ton male of her own species, she would have looked remarkably smaller.
And females also likely had much smaller tusks, which mirrors the dynamic we see in modern elephants today.
Makes sense.
They didn't need the extreme, exaggerated weaponry that males use for dominance displays or combat, which probably made foraging in those dense forests a bit easier for them.
I bet. Now, here's where it gets really interesting, though. If you look at the title of our source, or any formal scientific paper mentioning this animal, the word mammoth is always written in quotation marks.
Yes, the famous quotation marks.
It's this glaring grammatical anomaly in the middle of formal scientific classification. Why are scientists essentially using air quotes when they talk about this titan?
To understand the quotation marks, we have to look back at the history of how this animal was named and the intense debates it sparked.
Okay, take us back.
The story starts in 1834. An American naturalist named Isaac Hayes described a fossilized tooth discovered in Italy. He named it Mastodon borsoni, honoring Professor Stefano Borson, who had originally studied the tooth. But as paleontology advanced over the decades, scientists tried to organize these ancient creatures into proper branching evolutionary family trees. That's when things got incredibly complicated.
Because over the years, experts argued fiercely about where this giant belonged. Some argued it was clearly a species of mammoth.
Yes.
But there's a massive geographic problem with putting it in the mammoth genus, isn't there?
That's exactly the problem. The type species for the genus Mammut is the American Mastodon.
Which lived exclusively in North America.
Exactly. So putting Borson's Mastodon in the exact same genus implies a massive intercontinental migration. Either the ancestors of the American Mastodon marched from Eurasia over to North America, or vice versa.
Did they?
Some historical scientists really champion this idea, but there is absolutely zero fossil evidence to support a migration of mammoth across the Bering Strait land bridge.
So if they didn't march across continents, how do we end up with two animals on opposite sides of the planet that look so incredibly similar that scientists initially insisted on giving them the exact same name?
This brings us to a beautiful concept in evolutionary biology called parallel evolution.
Parallel evolution.
Right. The similarities between the North American mastodons and the Eurasian mammoth borsoni aren't because they are direct, immediate siblings.
Okay.
They independently evolved similar traits from a much older shared ancestor. In this case, that shared ancestor is likely a creature called Zygolephodon turacensis.
Zygolephodon turacensis.
Exactly. The two lineages split and were separated for millions of years. But because both groups were facing similar environmental pressures on their respective continents, browsing in dense forests, supporting massive body weights, they essentially found the exact same evolutionary solutions completely independent of one another.
That's like two different chefs on completely opposite sides of the world, independently inventing the exact same recipe for chocolate cake.
That's a great way to put it.
They taste the same, they look the same, but their kitchens have completely different origins.
And the scientific community recognized this issue. If they officially grouped them together in the genus Mammut, it would ruin the evolutionary family tree.
It would make it inaccurate.
It would create what's called a polyphyletic group. Think of it like putting a shark and a dolphin in the same biological family folder just because they both have fins and swim in the ocean.
Oh, I see.
They look similar on the outside, but their evolutionary blueprints are completely different. The quotation marks are the scientific community's way of saying, we know this creature looks exactly like a mammoth, but we also know it's technically an evolutionary imposter.
An imposter.
Yes, and until we create a perfect new category for it, we're using this as a placeholder.
So if it's an evolutionary imposter, a creature just wearing a mammoth disguise, does its skeleton give away the secret? When you look past the sheer size of the animal, what do the bones actually tell us about who it really was?
The skeleton is the dead giveaway. Mammut borsoni is essentially a paleontological Frankenstein's monster.
Frankenstein's monster.
Yes, its anatomy is a bizarre, fascinating mix of its ancient ancestors and its parallel cousins. If you look at bones like the ulna and radius in the forearm or the femur in the thigh, the shapes look incredibly similar to the American mastodon.
Yep.
But if you look at the humerus in the upper arm or the tibia in the lower leg, those bones hold on to the primitive shapes of its much older ancestor, Zygolophodon.
Wow, so it really is a mix and match. The source also mentions the bones were surprisingly graceful, meaning relatively slender for an animal of this size. And there's some really weird specifics in the joints too, right?
Yeah, instead of throwing complex anatomical jargon around, think about your own elbow.
All right, I'm thinking about it.
Now imagine the bony tip of your elbow projecting out sideways, incredibly thick and heavily muscled.
That sounds painful.
Well, for them, that's the kind of highly specialized joint modification they needed. It was likely to support the sheer weight and mechanical stress of its massive front half. We see this mix and match anatomy in the skull and jaw as well.
Like with the tusks.
Right, the upper tusks completely lack the enamel bands that were present in its ancestors.
What about the jaws themselves? With an animal this big, eating must have been a full-time job. Did they have a specialized setup for chewing?
They apparently lacked permanent premolar teeth, which older, more primitive mastodons had, and the lower jaw is particularly interesting. The frontmost part is relatively short, but the weirdest part is the variation. Some individuals of Borson's mastodon still retain small, lower tusks.
Like a second set of tusks.
Yeah, that German female specimen we talked about had lower tusks about 6 inches long, but other individuals seem to have had completely tuskless lower jaws.
That's wild.
It really paints a picture of a species in the messy midst of an evolutionary transition.
Okay, so we've built this colossal 16-ton body with 16.5-foot tusks, a mix-and-match skeleton, and placeholder quotation marks around its name. But what was going on inside its head? Do we actually know anything about its brain?
We do, and it is an extraordinary piece of the puzzle. A brain case was discovered in Moldova that preserved the internal hollow space occupied by the brain.
What scientists call an endocat.
Exactly. When we look at that Moldovan brain case, we have to talk about the encephalization quotient, or EQ.
EQ.
Right, EQ is a way of measuring brain size relative to total body mass. Despite this animal weighing up to 16 tons, scientists estimate the brain of the Moldovan specimen weighed only about 4.7 kilograms.
Wait.
That is roughly 10 pounds.
10 pounds. In a 35,000-pound body.
Yes. When you compare that to modern elephants, Borson's mastodon had a significantly lower EQ. Its brain was proportionally much, much smaller.
That is a tiny brain for such a massive animal.
It is, but smaller doesn't mean useless. The shape of the endocast is highly revealing. The areas responsible for higher-order thinking weren't massive, but it shows a prominently developed temporal lobe.
Okay.
Even more striking, the front tips of the olfactory bulbs, the part of the brain dedicated to processing smells, are clearly visible and massive.
Huge olfactory bulbs.
Yes. In the American mastodon, those olfactory bulbs are way less prominent.
We think of elephants today as highly emotional, intelligent creatures that mourn their dead, use tools, and solve complex puzzles. But this titan was playing a completely different evolutionary game, wasn't it?
It really was. It didn't need a supercomputer for a brain. It was an animal deeply, profoundly tied to its sense of smell.
Fascinating.
You have to imagine this multi-story giant moving through ancient forests, largely guided by a highly sensitive nose, sniffing out specific types of foliage, finding water sources in droughts, and locating mates across vast distances.
So it wasn't solving puzzles.
No, it survived for millions of years by being the biggest, heaviest, best-smelling tank in the forest. It interpreted its massive world through a sophisticated chemical landscape of scents, rather than relying purely on complex problem-solving.
And what a world it was. Let's map out the neighborhood this giant lived in. Where exactly did this biological tank roam, and for how long?
Its domain was vast. Fossils have been found everywhere, from the Iberian Peninsula in Western Europe all the way across to Greece, Ukraine, Turkey, and even as far east as Shaanxi in northern China.
So practically across the entire Eurasian landmass.
Pretty much. It spanned an incredible stretch of time, roaming from the late Miocene around 9 to 7 million years ago, all the way to the early Pleistocene, roughly 2 to 2.5 million years ago.
A run of up to 7 million years is hugely successful for any species. To fuel a 16-ton body for that many millions of years, what exactly were they eating?
Scientists use techniques like dental microwear, looking at the microscopic scratches left on fossilized teeth, as well as isotopic analysis of the bones.
And what did they find?
These techniques reveal that Mammut borsoni was a dedicated browser. It wasn't grazing on tough ground grasses like a modern cow. It was using its immense height to access leaves, twigs, and woody plants in the canopies of temperate Pliocene forests.
Now, I want everyone to picture the daily life of this browsing titan. It wasn't alone in those temperate European forests. What else was walking around in this neighborhood?
It sounds like an ancient, surreal safari. Picture this 16-ton giant casually stripping an entire massive branch of its leaves.
Oh.
Walking through the underbrush nearby is an ancient tapir.
The tapir.
There's a bizarre extinct species of rhinoceros called Stephanorhinus sharing the clearings.
Wow.
If you look up into the trees our mastodon is eating from, you might see a species of monkey called Mesopithecus.
Monkeys, rhinos, and tapirs in places like modern-day France, Germany, or Greece. It's completely wild. But it wasn't just a peaceful herbivore paradise, was it? What were the predators like?
The predator dynamics in this ecosystem were intense. Sharing those same forests were giant cheetahs, Acinonyx pardinensis, and a fearsome saber-toothed cat called Homotherium.
Giant cheetahs and saber-toothed cats.
Now, a saber-toothed cat isn't going to take down a healthy 16-ton adult male mastodon. The sheer size of Borson's mastodon made adults virtually immune to predation.
Right, nothing is attacking that.
But those predators would have absolutely targeted the calves or the sick, which means the mastodons would have had to be hyper-vigilant, using that incredible sense of smell to detect a saber-tooth hiding in the tall brush.
And they even shared the forest with other giant elephant relatives, too. The source mentions Ananchus, another massive creature with a browsing diet.
Yes, Ananchus was a major part of that world.
It paints a picture of a vibrant, highly diverse, ancient European ecosystem that feels utterly alien to us today. Yet, for millions of years, this deeply intertwined community of giant mammals was a stable reality. It was a functioning, thriving world that existed long before humans ever arrived on the scene.
It was a world of giants that operated in a completely different ecological rhythm than anything we can observe today.
As we wrap up this deep dive into the source material, let's look back at the key aha moments we've uncovered. We started with the sheer mind-bending scale. A 16-ton animal carrying 16.5-foot tusks that weighed 300 pounds each, requiring insane muscular engineering just to walk.
Incredible engineering.
We unraveled the mystery of its quotation mark name, discovering how parallel evolution allowed two different lineages to independently build almost the exact same biological machine on two different continents.
The evolutionary imposter.
Exactly. We peeked inside its skull to find a relatively tiny 10-pound brain that prioritized a hyper-powerful sense of smell over complex intelligence. And we placed it right in the middle of a wild ancient Europe filled with giant cheetahs, monkeys, and saber-toothed cats.
Synthesizing all of this raises an important question, one that touches on the very nature of history and deep time.
What's that?
We only know that Mammut borsoni existed. We only know that it was perhaps the largest land mammal ever to walk the earth because of a few scattered teeth, some partial skeletons buried in Greek dirt, and a single preserved brain case in Moldova.
Just fragments.
That is all that remains of an evolutionary dynasty that lasted millions of years. It leaves you wondering, if a creature this massive, this widespread, and this successful can completely vanish into the depths of deep time, leaving behind little more than a taxonomic puzzle with quotation marks around its name, what massive realities of our current world, what defining giants of our modern era might be completely invisible to the scientists of the distant future?
That is an absolutely brilliant thought to leave everyone with today. It really puts our own place in the grand timeline of Earth into perspective. Thank you so much for joining us on this deep dive into the source material. We hope you walk away today feeling a little more connected to the ancient, giant history of our planet. Keep asking questions, keep looking at the world with curiosity, and keep digging into the fascinating mysteries of the past. Catch you on the next deep dive.